This makes the diffusion of water osmosis easier because the membrane is selectively permeable. Osmosis caused some of the water in the vinegar to enter the eggs. This explains why there was less in the vinegar in the beaker. One of the main variables that could have affected the experiment was the amount of the vinegar added. The amount of vinegar could In the experiment, the bubbles are formed because of the chemical reaction between the acid in the vinegar and the calcium carbonate. The chemical reaction continues until all of the calcium carbonate is used up, leaving only the membrane behind. The eggs float because as the shell dissolves, the eggs get lighter. Once the shell is gone, only the membrane remains.
Hello guys! So for today, I would like to share some simple experiment that you can try at home. Firstly, you need 1 water bottle, baking soda, a balloons and vinegar. Next is we put some baking soda in the balloon using a tablespoon and then pour 5 ml of vinegar in the water bottle. After that, put the balloon that contains baking soda on the top of the bottle. Hold the balloon upward to mix the soda with vinegar in the bottle. You can see the changes size of the balloon and you also can see the reaction of baking soda with vinegar. At the end of my project, I have discovered that the vinegar and baking soda did create a chemical gas that filled a balloon, but did not make the balloon fly off the bottle. These two chemicals react to form carbon dioxide gas. This reaction caused the carbon dioxide molecules to rise and become trapped in the balloon, covering the top of the pop bottle.
A chemical reaction is when two molecules interact and they change. Exothermic reactions are reactions that transfer energy to objects around it. It is usually transferred as heat, making the texture and its surroundings hotter. In our case, the foam and the plastic bottle become hotter during and after the reaction. In this experiment, our purpose was to test how the percentage of the hydrogen peroxide and its amount affect the speed of the chemical reaction. Our hypothesis stated that the trial using the 30% solution would be the fastest, and it was proven correct. It was because it had more pure hydrogen peroxide, making it have more oxygen when broken down and pushing the foam out faster. The rest of our trials were slower than the first, even though there was a bigger amount of hydrogen peroxide used, because we used hydrogen peroxide of 6%, which has a lot less of pure hydrogen peroxide.